a while to take this to the fourth power. It's not a blink, right? So I'm going to say that y equals x to the third plus 3x. But now the problem is, do I have dy in the problem? If I have dy in the problem, I'm on the right track with this. If I don't have dy in the problem, I may have to come back and rethink the whole thing. So dy is the derivative times dx. The derivative of this function is 3x squared plus 3. Do I have this in the problem? Because this eventually, all this piece, will be replaced by y to the fourth. And what is left? Well, I noticed something here, that I could factor out a 3. If I factor out a 3, then I have x squared plus 1. This is in the problem. I have dx. It's in the problem. I don't have the 3. Not a problem. I can multiply by 3 and divide by 3. And now all this piece is dy. 3, x squared plus 1, and dx, all 1, 2, 3 factors will be replaced by dy. This whole piece will be replaced by y to the fourth, and so what? And I have a 1/3 in front. That's what I said here, except just a constant, a factor. I can always make that up. So now the integral becomes 1/3 the integral from y to the fourth dy. So something that started quite widely in a way, reduced to this with the appropriate substitution. This, I have no clue. This, super easy. So this is 1/15. Y to the fifth has to be replaced. So this is x to the third plus 3x to the fifth power plus a constant c. And something that looked horrible initially, it changed into very simple and into the antiderivative, or the most general antiderivative. So notice one thing. If the function has x, I have dx. If the function has y, I have to have dy. I can't have a combo of x and y in the same problem. Any questions before we choose the next one?
Where did the 1/15 come from? I know where everything.
So if I decide to multiply, I multiply by 3 and divide by 3. I needed a 3. I was missing the 3 here. I needed a 3. So I multiply by 3, but I have to immediately divide by 3. This is 1. Multiplying by 3 and divided by 3 didn't change anything. It's 1. But this and this and this now are dy. The 1/3 has to stay outside. 3 was incorporated, but 1/3 stays outside. And now, which function prime is y to the fourth? Is y to the fifth over 5. Because when you differentiate this, you get y to the fourth.
Okay, I see. Well, yeah.
So if you factor out something for the substitution, you have to multiply by the reciprocal for the whole integral.
Yes, because
Okay.
for example, if I have $10 in my pocket and I'll decide, oh, let me multiply it by 2. Do I have 20? No. But if I multiply by 2 and divide by 2, I still have 10.
Gotcha.
So I needed another way would be to solve. You can solve for x squared plus 1 times dx, and you are going to get dy over 3. because you have to replace this product. So you solve it in this equation, you solve for this and you write dy over 3. So you'll still have a 1/3 outside. And that's another way. And then when you find the antiderivative, then you have to multiply these two and you get 15. At any point in time, it's an indefinite integral. Here is our claim. We will not be able to do this with a definite. We can only hope. I differentiate the left-hand side. I bring down 5, so it's 1 over 15 times 5 times x to the third plus 3x to 5 minus 1, which is 4, times the inner function prime, which is 3x squared plus 3. The constant prime is 0. These two go away in the sense that I have 1/3. I factor out a 3 from here, and then I have x to the third plus 3x to the fourth times x squared plus 1. This will go away, x squared plus 1, x cubed plus 3x to the fourth, and this is 1. Is that better?
Yes, thank you.
Thank you. Okay. Should we work more on indefinite or move on to definite? Okay, let's look at 29. 29 caught my eye as 5 to the t power sine 5 to t dt. And I lost my count here. Gee, I lost my count like 15 minutes ago. I can't. If I drop them, it will take me a while to put them back in order. Okay, now I would like you to come up with a substitution. Let y be. Y, u, anything, any letter you like. You can use a if you want, anything, it doesn't matter, as long as you don't use t. So make sure for this problem we cannot use t. So, any suggestion?
5t.
Very good. Okay, so Vy, remember, this is not e to t. That will be e to t times natural log e, which is 1. So then this is 5 to t times natural log t times what? It's dy. What do I need to multiply it by?
dt.
Excellent, thank you very much. Okay, I have 5 to t. I have dt. This piece will definitely change into what?
Sine of y.
Excellent. So now this piece is there, this piece is there. What do I multiply and divide by to make it work?
Natural t.
Right. So you can put it anywhere you want. So natural log t and 1 over natural log t in front, so this is 1. But now 1, 2, 3. 1, 2, 3. So 1 over natural log t stays in front. The integral becomes, can anyone dictate the integral now?
Would it not be 5t or 5t?
So
or
1, 2, 3, all these are
Sine
here.
y dt?
That's sine I dy.
Dy. Yeah. Sine.
Exactly. We're going to go back to t in a moment. So in front I have 1 over natural log t, and then which function prime is sine t? sine y I meant to write, or to say, of course. So negative cosine y. And now we just have to plug it back in. What is y? 5 to t. Let's say you have doubts. Very easy, which we cannot do for definite. So we claim this. Okay, so let's differentiate this side. So when I differentiate cosine of 5 to t, I get negative sine with minus in front. So this is sine to 5t times the inner function prime, which is 5 to t times natural log t over natural log t. And when I differentiate the constant, it goes away. And when I differentiate this side, I get 5 to t sine applied to 5 to t. Any questions? You do not have to check, but I just want you to remember that the indefinite integrals are very nice and friendly. We can always go back and check. Okay, let's look at the substitution rule for definite integrals and what is different. Okay, let's start with a 60. 60 on page 414, of course. And that is the integral from 0 to 1 from x e to negative x squared dx. And you could say, how is that possible? You just told us that you can find an antiderivative for that. True. But I didn't say this one. For this one we can. But for this one we cannot. But for this one we can. Good, so give me a y, or u, or t, or v, or a, whatever, but not x in this case. What do you think? There is a piece there that I really don't like it to be there.
Negative x squared?
Yep, perfect. Perfect. As long as du can be easily made up. So what will du equal to?
Negative 2x.
Not just.
2x dx?
Great job. I have the x. I have the x. I have the I have x, I have the x, but I'm missing something. What am I missing?
Negative 2.
No worries. I multiplied it and divide by negative 2, which means 1. I didn't change anything. Everything is good. I copy negative 1/2. Do not copy the limits of integration. Just tell me for now, what do I write in here? Do not copy the limits of integration. So what do we have in here? What do I write?
Is it e to du? Or is it?
E to u du. Awesome. Exactly. E to u and everything else. These three pieces are du. Now I have to decide upon the limits of integration. You understand that these are the limits of integration for x. I cannot copy them for u. It's not possible. So when x is 0, how much is u? When x is 0, how much is u?
0.
Excellent. When x is 1, how much is u? That's what I have to copy up here. For the lower limit, I plugged in 0 and I got the lower limit. For the upper limit, I plugged in 1 and I get
On
Negative.
negative 1.
that's it.
1. Oh.
That's it. So I have negative 1/2 in front. What function prime is e to u?
ECU.
Very good. From 0 to negative 1. Notice the difference. And there is basically only one difference. We're not going back.
Wait, I have a question. So,
Yes.
since negative 1 is the upper limit and it's less than 0, does that matter? Or
No, it doesn't matter anything.
Okay.
Because I can switch these and change the sign here.
Okay.
It doesn't matter. So notice what happened here all the time. We went back to the substitution. Who cares now? No one. It's going to be a number. If I solve in x or in u, it doesn't matter. I changed correctly the limits of integration, so this will be the same number that if I go back and change back to x. Do not go back. There is no need to go back to x. So I copy negative 1/2. I plug in negative 1, which is 1 over e, minus when I plug in 0, I get 1. And no, don't ask me to check, I can't. Because if I differentiate this, I get 0, and that's not 0. So we cannot check the definite integral. So please do not go back. There is no need to go back to the variable you started with. Okay, let's take a look at, yeah, why not? 71 caught my eye, I don't know. 71, same page, 414. The integral from 0 to 1, from e to z plus 1, over e to z plus z, nice. dz, wow, a lot of z's in there. Okay, where do I look? If you ask me, I'm going to say I don't care for the numerator. The numerator is composed of a sum of two terms. Who cares? I am bothered by this denominator. Why am I bothered by this? Because I cannot do anything to this. There's nothing I can do to simplify. Whenever the denominator has two terms or more, I don't have a way of doing anything. So if I make this disappear somehow, if I make that disappear, I think I can solve and determine the antiderivative. So let's say let u be e to z plus z. As long as du is in the problem, I'm on the right track. If du cannot be manipulated to be in the problem, a z is missing or a z squared is missing, then I'm not on the right track. So what should I do? Any questions? Any questions?
You're asking what comes
Yep,
next?
yep.
Oh, okay.
So just tell me what is du.
E to the z
Yes?
plus z.
Plus, careful,
Oh, I'm sorry, 1
times,
d z.
that's it. Here it is. I love it. The integral, do not copy the limits of integration. Can anyone tell us how to write this?
So
One,
d
yes, you can write du over,
u.
yep. Or you can write 1 over u times du, which is the same thing. I need the limits of integration. New ones. I cannot copy the old ones. So when z is 0, what do I get here? And that's the limit, the lower limit for z. I'm sorry, for u, of course.
So 1.
Yes. Very good.